Hey guys, Mr. Backenberg here. In this video we're going to look at increasing and decreasing functions. So as far as the formal math definition of an increasing function, we say a function is increasing on an interval if for any 2 points on the interval a positive change in your x value results in a positive change in your f of x value. And remember, your f of x value is just your y value. So essentially what this is saying is as we read our graph from left to right, as those x values increase, what we're looking for is a positive change in our y values. So our graph, as we read it from left to right, is going to be going up. That's what it means for a function to be increasing. So as far as a decreasing function, a function is decreasing on an interval if for any 2 points on that interval a positive change in our x results in a negative change in our f of x, or in our y value. So as we're reading our graph from left to right, decreasing means that our graph is going down. And then a function is constant on an interval if for any 2 points on the interval a positive change in our x results in no change in our f of x. So this would just be a flat horizontal line. So when we're looking at describing functions as increasing, decreasing, or constant, I think the easiest way to do it is by looking at the graph. And we're just going to read our graph from the left to the right, and we're going to try to describe what's happening. Now we will be writing out where our graph is increasing, decreasing, or staying constant using interval notation. And when we write out our intervals, we always want to write them out using the x values from our graph. So as we're looking at this first example, we're going to look at the function f of x equals 3x minus 2. And we're going to graph this out on our calculator. So I've already got my equation typed into my calculator, and we're going to look at the graph. And like I said, we're going to read the graph from the left to the right. So we're starting as far left as we can, and we're reading it to the right. Now we know, since this is a y equals mx plus b equation, that it's going to create a line. And since this line has a positive 3 slope, our graph is going up as we're reading it from the left to the right. Now we know, since it's a line, that this graph doesn't have any other behavior. So let's look at writing out the intervals and describing what's happening. So again, since we know that this graph for our function is a line with a positive slope, we know that it's always heading up. So we can say this graph is increasing, but we want to write out an interval for where it's increasing. And since our graph has a positive slope, as we're reading it from left to right, it's always going to be increasing. So as we look at the interval, it's going to be from negative infinity all the way up to positive infinity. So our graph is always increasing as we read it from left to right. Now we're going to look at another example here. This time we're going to look at the function f of x equals x plus 2 squared. And just like we did before, we're going to look at the graph to help us out. So I've already got my equation typed into my calculator, so I'm going to hit graph. So we can see that our graph has a parabola shape, and it starts, as we read it from left to right, it starts coming down until we hit that x value of negative 2, and then it starts going up. So we're going to use that to help us write out the intervals and describe what's happening. So as we looked at our graph, the first thing we saw was that our graph was going down, meaning that it was decreasing. Now we always start as far left as we can, so this first interval is going to start at negative infinity. But now we have to try to figure out where our graph stopped decreasing. And again, we're looking at the x values. So when we got to that x value of negative 2, our graph stopped going down. So I'm going to close this interval at negative 2. Now negative 2 does get included since the point was on the graph. There is an actual point at negative 2, so we include it there. But then at negative 2, something else started happening. So I need to open up a new interval at negative 2. And what happened was that our graph started going up. So it was increasing. And we couldn't see our graph making any other changes. And since this one is a parabola, we know that this graph would just continue heading up. So to end this interval, we're going to go all the way out to positive infinity. So this graph had two behaviors. It started out decreasing until we hit -2, and then it turned around and started going up. We're going to look at one more example here. So we're going to look at the function f of x equals x squared over x squared minus 1. And we're going to look at the graph to help us out. So in my calculator, I already have that equation typed in, so we're going to graph it out. Now we can see there's a bunch of different things happening here. As we start from the left to the right, it looks like it's constant, but if we look up here, there's this little jump in the graph. So it is actually increasing here. Now it looks like there's going to be an asymptote in here at -1, and it also looks like there's an asymptote at +1. So that's going to adjust our behavior just a little bit. So this graph goes up, but then we have to jump down here to this other part. We're still going up, but then when we hit 0, we flip over and we start heading down. And then we've got that other asymptote in there, so we have to jump up to this other part of our graph, and it looks like we're coming down again. This is a very, very gradual decrease here. We can see a very small dip in the graph, but it is actually decreasing. Your calculator just can't show how little it's decreasing just because of the pixelation of the graph. So as we look at writing out these intervals, the very first thing that we saw was that our graph was going up, so it was increasing. And we always start our first interval at -infinity because we're starting as far left as we can. And as we were reading from left to right, our graph was going up, but then we had an asymptote at -1. So that actually splits our graph. So I'm going to close this interval at -1, and -1 doesn't get included because of that asymptote. But then what we saw is that our graph kept going up. Once we jumped over to that other part, there was another increasing interval. And that one was increasing from -1 until we hit 0. Again, we're not including -1 because of that asymptote there. But 0 does get included. 0 was an actual point on the graph. So both of these intervals are increasing intervals. But then our graph changed its behavior. Then it started going down from 0. So that's a decreasing interval. And again, we're including 0 because there was an actual point on our graph at 0. And we're going until we hit that other asymptote, which was at +1. And I'm going to close the interval there, not including 1 because of the asymptote. And then our graph jumped up to that other last section, and it was still decreasing from 1 out as far as we could see. So that's going to run out to +infinity. So this graph has 2 increasing intervals and 2 decreasing intervals. That's going to be it for this video. Thanks for watching.